Are you?
Okay, so yeah, I'll go ahead and switch here. So my name is Enrique, and we're going to be basically picking up where we left off yesterday with looking at a little more JavaScript. So we're going to be going through a workshop, exploring JavaScript and what we can do with it. So for today, we're going to try to make something with JavaScript. And what that is essentially a little snaking game. So let me show a quick demo for this over here. So essentially, we're going to be making this. So this snake, if we refresh, we can basically control this snake. And just a classic snake game, we can move the snake around. We can go and eat the food over here. And as we eat the food, our snake will grow longer and longer until we either run into a wall or we run into ourself, in which case the browser will pop up a little window that says game over. So that's basically what we're going to be making today. So some of the things that we're going to need, those 5 things. First, we're going to need to set up the game. We're going to need to make sure that there's some sort of game loop that allows us to run everything. Second, we're going to need to make the actual snake. Third, we're going to need to respond to inputs. So that's the keyboard, the arrow keys. Fourth, we're going to need to add the food. And lastly, we're going to need to add some sort of logic to end the game, essentially, have some game over state. So let's actually just dive right in and start getting set up and open up the starter code. So everyone open up your Catbook React folder as we did yesterday as well. Now this is the exact same folder that you were using yesterday. And run the following commands. So git fetch, git reset -- hard, and git checkout w1 starter. So that'll be the starter code for our workshop. So I'll give you all a few minutes to do that. I'm going to do this as well. And when you run this, you should see 3 files in the Explorer here. So, and I'll go over what these are in a second. Raise your hand if you need more time to get to the correct step. Okay, I'll wait a few more minutes. Okay. So let's take a look at the starter code. So as I mentioned, there's 3 files. There's this game.js file, there's an index.html file, and a style.css. If you remember from yesterday, these are the 3 main components of any website. So the game.js, the logic, the skeleton, the HTML file, and the styling, the CSS. And for this workshop in particular, we're not going to need to edit the style.css. So we're not going to be focusing on that. We're going to be focusing on JavaScript. But if you want to change the colors within the game or anything like that, feel free to do so. So the main ones we'll be focusing on are game.js and index.html. So now let's go ahead and try running the game. So to do so, there's 2 options you can do. You can open the index.html in Finder or File Explorer, dragging it into your browser. Or you can install an additional extension, the live server extension in VS Code. And you can start it by, there will be a little icon down here when you open index.html. And you'll be able to start the live server, and it'll open up your browser to and see basically what you have here. I think someone mentioned yesterday in the Piazza that there's also an additional extension you could use. So if you're familiar with ways to open up the index.html, feel free to do that. But any of these are okay. And the benefit of using the second option is that whenever you make changes, it'll automatically refresh your screen, your browser, to basically so you don't have to keep refreshing manually. When you've done this, you should see in your browser this canvas here, this black square. And this is going to be where we start off. So raise your hand if you need some more time to get this open. And of course, if you get stuck, feel free to add yourself to the queue or go to the questions. Okay, so again, this is what we're going to start with. So we have the blank canvas. And internally in the CSS that's already provided for you, we've broken this square down into a 21 by 21 grid. So this is kind of a visualization of what that grid looks like. At the top left, we have the coordinate 1, 1, and the bottom right, we have 21, 21. And the snake is represented as squares within this grid that we can move around. So let's go ahead and actually start coding. So let's make sure that you've checked out W1 starter. So we're going to go ahead and start step 0. So the first step is to actually create the game loop. And we want this game loop to run 5 times per second. So let's go into the code and let's open up game.js. And here, by the way, let's see, get this to work. Here we can see on the top right, you'll see the files that we're going to be working in. So in this step, we're going to be looking at game.js and index.html. It's the only 2 files that we have so far. And what we're going to do is 1, create the game loop that runs 5 times per second. And 2nd, connect the game.js file to the index.html. So if we look at the code here for game.js, we can see there's a couple of functions. There's this main function that calls these other 2 functions, update and draw. Update will basically handle all our logic for the game, and draw will draw the content to the browser, to the screen. And here you can see we have this set interval function. This was briefly mentioned yesterday. What this function does is it essentially calls another function after a certain delay over and over again, repeatedly until you end it. Basically infinitely until you somehow end the set interval. And you can check out the documentation at this link here. So what I'm going to do here to get started is I'm going to put a console.log in the update function just to see what this set interval is doing. So I'm going to say updating. And if I go into, and one thing I need to do, I'm going to go ahead and actually do step 2 right now. I'm going to connect the index.html, the JavaScript file to the index.html. And the way that I do that is by using this syntax here, script, and then have the source equals, and then the script name that you want. So in this case, I'll do script. So feel free to follow along here. Source equals, and then game.js, because the file that we have is called game.js. And so if we go here, we can now see in the console that there's this print statement that's happening here many times, basically infinitely. This is going to run forever until we close the browser, or stop our code. And so let's try to make this run, instead of running this quickly, let's try to make it run only 5 times per second. So take a couple minutes, look at the documentation, see if there are any additional arguments you can pass into this function, and try making it run, instead of this quickly, try making it run 5 times per second. Okay, does anyone have any ideas on how we could do this? Any ideas? Yeah. Okay, yeah, exactly. So what we're going to do is add an additional argument, which will say what the timeout is, what the delay is between the calls to main here. And so if we want something to run 5 times per second, we'll set that delay to be 200 or 1000 milliseconds divided by 5 here. So this will run the main function once, wait 200 milliseconds, call it again, wait 200 milliseconds, and do that forever. And instead of having this just random number here, 5, let's create this into a constant. So let's say snake speed. And let's go ahead and define snake speed at the top here using a constant. So const snake speed equals 5. Let's save this. And hopefully we should see that now the update function is running a lot slower. And so this is kind of a more reasonable speed for our snake. Otherwise, the snake would be moving way too fast. Okay. So let's take a look here. So yeah, this is basically what we did. We created the update function. We added a little console log there. We set the interval so that the function runs only 5 times per second. And then lastly, we connected the game.js file to index.html. Okay, so to catch up, let's run git reset -- card git checkout w1 step 1. And it's important that you actually do this even if you manage to write all the code yourself, because there's some additional stuff that we've added to this step that you'll need. So I'm going to run this as well. Git reset -- hard and git checkout w1 step 1. And so here's our next step, the snake. And there's two there. You'll see that there's an additional file here that we've added, snake.js. And this will contain all of the logic and drawing functionality for the snake. And we're going to be working in this file as well as also back in game.js. So, and so the 4 tasks that we want to do is 1, create the snake body, 2, create a function to move the snake, 3, update the snake in the game loop, and 4, connect the snake file to the HTML. So let's actually go backwards and start with step 4, just connecting the snake file. So it's basically the same thing as before. Feel free to follow along again. Script, source, and then we can say snake.js. So that'll make sure that whatever changes we make here are going to be actually be used in our HTML file. Okay, so for step 1, part 1, let's create the actual snake in snake.js. So the main question here is, how do we want to represent the snake in JavaScript? So as a hint, I'll say that we can recall the grid that I showed earlier, the 21 by 21 grid. And we can represent the snake in this way, as we can see in this diagram. It has a bunch of coordinates. So does anyone want to see if they can figure out how we're going to represent this snake in like a JavaScript data structure? So any suggestions for that? Yeah, in the back. Object? Yeah, essentially we're going to need an object representing the coordinates. So we're not going to use an object specifically for the entire snake. We're actually going to be creating an array. And inside that array, we're going to be using an object to represent the X and the Y coordinates. So here we have the snake body representation in JavaScript. So we have the array that has the coordinates 11, 11, 11, 10, and 11, 9. And so let's go ahead and code this. And you can see here in the array that the first element, it will represent the head of the snake. So I'm going to go ahead and write this. Let's see. Snake body. And then we're going to say X is 11, Y is 11. So this will be the head again. The middle segment will be X is 11, Y is 10. X is 11, Y is 9. Okay, perfect. Okay. So the next part is to create a function to actually update and move the snake. So I've also provided a hint here. So we have the original snake diagram that I showed earlier. And then to move the snake, we might want to do something like this, where we remove the tail of the snake and add a new block within that snake that essentially is moving that snake forward. So I'll let you all try this for a couple of minutes. You're going to be working here in snake.js. There's a to-do here. And there's also some additional hints that you might find useful. There's some functions for array that you can use. So yeah, take a few minutes to try to implement this yourself, and then I'll show the solution that we have. Okay, so let's see how we decide to implement this. So the way that what we want to do is essentially as shown in the diagram, we want to remove the tail of the snake, so this last segment, and add a new element to our array, to our snake array, and at the new position. So in this case, it would be 11, 12 if we want the snake to move down. So we're going to create a function. Let's call it update snake. And we're going to first remove the tail segment. And if you looked at the documentation for this pop function, what it does is it'll remove the last element from the array. And so that's exactly what we want. So we can basically just say snake body dot pop. That'll remove the snake's tail. Then we're going to want to create the new segment for the snake. So we're going to essentially copy the old head of the snake and add it on to the snake again, but at a new position. So we're going to say new head. And if you remember yesterday, we can use this destructuring operation to get the X and Y coordinates. And we'll get the old head of the snake by getting the first element of that. Then we're going to update the head's position. So we're going to say new head.x. Since we want the snake to move down, we don't really need to change the position of the head of the x coordinate. So we can say 0 for that. But for the y position, we do want to increase it by 1. So 1 will represent moving downwards. And then lastly, again, if you looked at this unshift method, what that does is it inserts an element to the front of an array. So we can do that to add the snake body, to update the snake body. And then new head. Okay. So that should be about it. And then the last thing we need to do is call the snake updater function in the game loop. So if we go into game.js and we see this update function, and you can see this to do here, we can basically just call the update snake function. And because we're running this update function over and over again, this function update snake will also be called over and over again. And if we did this all correctly, we should see that we now have a snake on our screen, and the snake just basically just moves down infinitely. So yeah, any questions so far? All right, cool. So there are the solutions for the last 2 steps. Okay, next we're gonna actually respond to inputs. So let's do run again, git reset dash dash hard and git checkout w1 step 2. Again, even if you've made the correct changes, we want to run these commands anyways because we have new code for you to use. W1 step 2. Okay. All right, so for step 2, we're going to be working in in this new file here, input.js. You'll see it's created here. And also, again, game.js. So the tasks for this step are to add a keyboard input event listener, move the snake based on those inputs, connect the input file to HTML. And this 4th step is a tricky step, but important as well. Make sure the snake can't backtrack. It can't run back on itself. And I'll go into more detail on what that means. So let's just make sure that this file is already connected to the HTML. So let's just do that real quick. So we'll add the script again. It's the exact same thing as before. Input.js. Okay. And let's take a look at the first task. So first, we're going to create a keyboard input event listener for actually controlling the snake. So this is a special technique that we can use in JavaScript to actually refer to inputs taken in from the user on your browser. And so I'm going to get you all started with this by going into input.js. And if you look at the documentation, you'll see that the syntax for this is window.add event listener. And then you can use the key down function to check if a user has pressed a key. And this function, add event listener, also takes in a callback function. So a callback function in short is basically just a function that you pass in as an argument to another function. And so we'll create this little function here. And this function is provided with an argument called event. And then we can access the key that is pressed by using event.key. So we're going to use this function here, this event listener, to essentially check which key has been pressed. And if you look at this documentation here, the list of key values, you can see the different type of keys represented as strings that you can check. So if we, for example, search for arrow left, you'll see that it's basically just the string arrow left that represents the left arrow key being pressed. So I'll give you all a few minutes to try to figure out how we're going to read in these inputs and update the snake based on the inputs, based on the keyboard inputs. So again, there's a bunch of hints here. Refer to the documentation. And yeah, let me know if you have any questions. And as another hint, you can look at this diagram here. So you can try to think about where the new snake's head is going to be, given the arrow keys as our input. Yeah. Yeah, so when we create JavaScript files in a common folder here, and essentially what it allows us to do is it basically just gives us access to every single function across all files. Yeah, so from Snake we can reference files from game. Essentially, it basically just combines them into one big JavaScript file internally, and so we can just access anything from anywhere. Yeah. And the reason that actually works in the browser is because we've imported all the scripts here using the script tags. Okay, so let's take a look at how we decide to implement this. So what we're basically going to do, hopefully some of y'all got this as well. We're going to essentially create a bunch of conditionals to check which arrow key is being pressed. So as you can see on the right here, we have the key, the event.key, as I mentioned, and we're checking the specific key that's being pressed. And so we have these four conditionals for each direction. So left, up, down, left, and right and left. So let's go ahead and implement this. So we can create our four conditionals. So let's say if event.key equals, and again, remember we use the triple equals sign in JavaScript, arrow up. We're going to do something here. Else if event.key equals arrow down. Else if event.key equals arrow left. And lastly, event.key equals arrow right. Okay, so those are our four directions. Now, what do we want to do when we, press those keys? So what we're going to create is this input direction object that represents the change in the change in position of the snake's head. So here we can see we start with 0 and 1 for the X and Y. So let me create this. So I'm going to call this input direction equals X 0. Y1, and this represents a 0 change in the X direction and a +1 change in the y direction. So we're going to basically just update this input direction value depending on which arrow key has been pressed. So for going up, we're going to say x remains 0. The x position doesn't change, but the y position decreases by 1, so -1 here. If you remember, 21 is at the bottom and 1 is at the top, so we want this for moving up. Similarly, for going down, we basically just do x is 0 and y is 1. For left, we do x is -1. We want it to move to the left. Y remains at the same position, so 0. And then input direction for right is x is 1, y remains at 0. And then what we can do is at the end here, we can create a function called get input direction. Don't forget to add the const. And what this function will do is still just return the input direction that we have here in the file. Okay. And so for the next task, once we have this, we're going to go ahead and change the snake's position based on the user inputs. So if we go back into snake, we're going to use this new function that we created. And essentially, instead of just arbitrarily changing 0 and the head's position by 0 and 1, we're going to actually use the input instead. So what we're going to do is we're going to call that function, get input direction. We'll just get input direction. We'll save that into a variable. And again, instead of 0 and 1, we'll do snake direction dot x and snake direction dot y. Let me hide these. Okay. And again, here is our solution. It's the exact same thing. And I believe we already updated we updated the snake. So what we can do, what we should be able to see when we go back to our browser is that we can now use the arrow keys to control the snake. So hopefully you all can do this as well. You can just move the snake around. But one thing that you might notice is that if you're going up and you press down, the snake basically just goes into itself. And we don't really want this to happen. Normally this would just be a game over. The snake really is just crashing into itself. So we want to prevent this from happening somehow. Similarly, if we're going left, we don't want it to be able to just immediately go right. So that's going to be our last task for this step. We're going to ensure that the user can't turn back on itself. Basically can't crash into itself. And the hint that I'll give is that we will have to modify input.js to essentially prevent this from happening. So does anyone have any ideas on how we can actually do this? How can we prevent this snake from crashing into itself? Oh, yeah. Exactly. Yeah. So the key insight here is that we can essentially look at its current direction, the current way that it's traveling, and basically use that to make sure that it doesn't go in the opposite direction. So we're actually just going to use this input direction value here because whenever we go into this function, the input direction value will be the previous value that it was traveling. So let's say we go into arrow up. Let's say we're about to turn up. We basically don't want the snake to be traveling up and down. So essentially, we don't want the x to not be 0. We want the y to be 0 instead. So we can say input direction dot x does not equal 0. Let me go ahead and show the solution there. So essentially when the if the snake is traveling up and down, we don't want to be able to go up as well. So that will prevent that from happening. Similarly for down, we don't want to go up or down. So we want to say this the same conditional input direction dot x does not equal 0. And we essentially just do the opposite for left and right. We don't want the snake when going left to go right or left. So we basically say input direction dot y does not equal 0. And similarly for right, input direction dot y does not equal 0. Okay. And now if we go back here and refresh, we should see that even if we're pressing the down arrow key while going up, it doesn't really do anything. So that should be our snake fixed. Okay. Any last questions before we move on? Yeah. Yeah, so in snake.js, we can look here again. So we basically call the function that we created. So get input direction. And we basically use this. This will be an object with an x and y. And we basically add the position of, we add the snake direction to the new head's position. So if snake direction dot x is 1, it'll add 1 to the new head's x position. If it's 0, it'll add 0. And the same thing for the y. If it's 1, it'll add 1 to the y position of the new head. 0, if it's 0, -1 as well. And that'll essentially move the position of the next head to the correct location. Yep. Okay, so now I'll pass it on to Mark, and we'll be doing the last couple steps, adding in food and basically killing the snake so we can end the game.
Thanks, Enrique. So now the next step is step 3. So we're going to be working on adding the food for the snake. So in order to get catch up, get reset dash hard and get checkout w1 step 3. So what Enrique's walked us through so far is the game setup, where we utilize the game.js and index.html. Then we created the snake in snake.js. And then what we just did was work with responding to inputs in input.js, snake.js, and index.html. So after we check out step 3, we now have some extra files. So currently our code looks like game.js, snakeutils.js, which we just added with this new step, snake.js, food.js, input.js, index.html, and styles.css. And so now we currently have a lot of files. So maybe one question that you have is, why do we have to have the separate files? And as Enrique mentioned earlier, all the JavaScript files are really put together. But one reason why we might separate them is for modularity. So for example, we have game.js for maybe the game logic, snake.js for the snake logic, and so on. This also helps us avoid giant files that are hard to navigate. So if we put all of these files together, we maybe have hundreds of lines of code. But with being able to put them in separate files, we're able to keep track of kind of like what goes where. Next, we have that these files are small, clearly defined, and they're focused on some part of our game. And so it's easier to navigate within our code base. And lastly, it's easier to add new features to the game. So for example, with this step, we're going to be looking into adding food. So we added a food.js file to kind of keep track of the food logic. So currently, this is the file structure that we have. And since we added some new files, we're going to have to add those to our HTML. So if we go to our index.html file, we're going to actually have to add the food script. So we can just use the same things before to actually add add in the food. And so with that, we can start actually implementing food logic. So our goal here is to add food for the snake to eat during the game. And that kind of leaves us with three main tasks. The first is actually creating the food. The second being a function to update the food. And then we actually have to implement or add it to our game logic to update the food whenever we actually eat it. So during this step, we're going to be working in two files, food.js and game.js. And in this step, we added a snakeutils.js. So this snakeutils.js file kind of has some useful functions that we use for our game, such as on snake, seeing if two positions are equal, maybe growing the snake whenever we consume food and getting a new food position. And so maybe that this file and some of the functions here will be kind of useful actually in implementing some of the food logic. So these are the three tasks for this step. And I'll give you guys a couple minutes to kind of take a crack at this, and then in a minute or two, I'll actually give some hints on how to actually implement these. If anyone has any questions, feel free to raise your hand or ask on the queue or the question stop. So now for a few hints on how to actually implement these. For task one of creating the food, we're going to want to actually initialize the food. And to create a function to update the food, maybe a couple questions that we can think about is like, when do we actually want to update the food? And what else do we need to do when actually updating the food? And in step three for updating the food, where do we need to update it and how can we update it? Okay, so now let's go ahead and start implementing step 3. So the first thing that we kind of want to do is update I'll go back. We actually want to create the food. So in order to create the food, we can initialize some variable food, and we want to create some object here, which is actually going to store the initial food value. So maybe we want to store the initial food value at the x coordinate being 4 and the y coordinate being something like 16. So this will give us that initial food that we're going to see, and we can see it right here on tile 416. Secondly, we're going to actually need to create a function to update the food. So we need to actually initialize that function. So maybe we want to have a function called update food, which is going to take in no arguments because we just want to call this function to actually update the food. And so when do we actually want to update the food is whenever our snake is actually on the food. So here we're going to need an if, and if our snake is on the food, which was one of the functions that we provided in utils.snake, snakeutils.js. So if there's some position that's on the snake, which in this case would be the food, it will return true and false otherwise. So if our snake is on some food, we're going to want to grow the snake, which is another function in the utils file. And then we're actually going to want to have to generate a new food tile. So we can also use another function that we provided, which is get new food position. And then lastly, we actually need to update the food during the game. So in our game.js file, under our update function, we actually need to just call update food during the game loop. And so with adding that function in, whenever we refresh the browser and we move around and we eat the food, our snake should grow in length, but also eat the food. Once we eat the food, a new food object should appear. So really quickly, just to kind of like recap what we did. The first thing we did was create the food, and we did that by initializing some food variable as an object inside of food.js. Next, we had to create a function to update the food. So we made a function update food, and we checked if the snake was on the food. And if we did, we grew the snake and created a new food position. And lastly, we actually had to update the food location during the game. So this was our original update function, where we had to update the snake throughout each game step. But now we actually have to update the food as well. So with that, moving on to the next step, which is actually adding game over logic for if the snake hits itself. So to catch up, we can run git reset -- hard and git checkout w1 step 4. And so for this step, our goal is to allow the game to end. And that kind of leaves us with 4 tasks. The first being that we actually need to create a function to check if the game is over at any time step. We need to update whether the game is lost or not throughout the game. So currently the game is like always ongoing. So we need to be able to update to if the game is lost at any point. We also need to add a game over. We want to add a game over alert. So if the game ever ends, we want to be able to see it on our browser. And lastly, one thing we need to be able to do is because right now we have that set interval in our game.js. And so right now we're kind of like looping through, or every 200 milliseconds, we're updating the game. So we're going to actually have to do something with that in order to like end the game so that it stops updating. And again, don't forget about the utils file because we added some new functions here, out of bounds, snake out of bounds, and snake intersect self. And during this step, we're only going to be actually working with game.js. And so again, we're going to have 4 tasks: create the function, check if the game is over, update where the game is lost. We're going to want to add a game over alert, and we're going to want to define the interval ID and clear interval. And so for that last step, it would be helpful to refer to the documentation for set interval to kind of see what we can kind of do with this function. Depending on what version of VS Code you have, you might be able to hover over the set interval function here after you click on it. And after a second, you will see this MDN reference come down. And if you click on this and you open it, it'll load in the browser what the documentation for this. Otherwise, you could just search set interval with the MDN docs, and it should come up as well. So I give everyone a couple minutes to kind of try to implement some of these. And then I'll put up some hints in a couple minutes. Okay, so now I'll give a few hints to implement these. So for the first task of creating a function to check if the game's over, we want to remember our utils file and some of the functions that we added there, particularly these last 3 functions. And also in JavaScript, the double ampersand is an and the 2 like absolute value bars is an or. For step 2 on updating whether the game is lost, one question maybe we could ask is how can we keep track of like if the game is still ongoing? For the third step of adding game over alert, our syntax for alert that we mentioned yesterday during the JavaScript lecture is alert with whatever we want to pop up on the browser inside of the parentheses. And maybe another question is when do we actually want to send the alert? And lastly, for the 4th step, we want to check the empty indocs for set interval, which is here. So the syntax for set interval is kind of here. And so the set interval function is a method that returns an interval ID, which identifies the interval that we're working with. And so we can remove it later by calling clear interval. And so this will be helpful in that last step. And so that actually covers hint B, is that we can remove our game loop by calling the clear interval function. And if we go to the documentation for that as well, we can kind of see that the parameters for this function is an interval ID. And this is the ID that's returned by the corresponding call to set interval. So I'll give everyone like another minute or so, and then we'll walk through on how to implement all of these. Okay, so with that, we're going to start implementing step 4. So for the first task of creating a function to check if the game is over, we can maybe create a function check game over. And we want this function to just check if the snake is out of bounds or if the snake intersected itself. And so if either one of these is true, then this function will return true. And if they're both false, it'll return false. And so to actually keep track of like how our game's going, we're going to need to create some variable, maybe called is game over. And whenever we start the game won't be over, so we can go ahead and set that to false initially. And this kind of works well with the function that we just added, because if our snake ever goes out of bounds or the snake ever intersects itself, it'll update to true. Or we could update it to true rather. And so now that we have our function to check whether the game is over and we have a variable to keep track of it, during our update function, we're actually going to have to update the game state, which is step 2. And so to do this, we can just redefine is game over and call our check game over function that we just added. And every game loop during the update step, we will check whether the game is over and update the game state. The game is game over accordingly. Next, we're going to want to add a game over alert. So we want to do that during our main function. So in order to add our game alert, we only want to actually send this alert if the game is over. So we want to check first if if the game is over. And if the game is over, we want to raise an alert, and maybe we want that alert to say game over. And lastly, for the last step, we want to define the interval ID and clear the interval whenever the game is over. So in the documentations for set interval, we have that set interval returns an interval ID, which identifies our interval. So initially, we just called our function set interval, but we didn't actually define it as anything. So now we're going to actually want to define this something. So we'll let our game loop equal the ID that comes back from this our function set interval. And now that we actually have the interval ID, at the end of, if the game is ever over, we're going to want to clear the interval. And that will like end the game and stop it from updating. And so with that, that actually is the end of step 4. So just to recap super quickly, to check if we created a function to check if the game was over. So we created some function check game over, which checked whether the snake was out of bounds or if the snake intersected itself. Then we had to update whether the game is lost by creating some variable game is game over, which is always set to false. And while our game is updating in our update function, we had to reset or manually assign is game over to the new checking if the game was over in each time step. Next, we had to add a game over alert. So we used the syntax from yesterday, checking whether if the game was over, and if it was, sending an alert that said game over. And lastly, we had to define our interval ID and clear the interval ID if the game ever ended. And so now, if we go to our browser and we refresh our game, and we can still eat the food as we were able to before. And if we ever intersect ourselves or run out of bounds, we'll get an alert on our browser that says game over. And so since the game actually ended, here that we cleared the interval, we see that the game freezes and it doesn't actually update anymore. And so now we have a finished game. So to get the finished game, you can git reset -- hard and check out w1 - complete. And we're going to break for lunch in a couple of minutes, but just to give a challenge, if anyone wants to try to implement it, the challenge is resetting the game. So currently, whenever we actually end the game, our browser freezes, and whenever we're playing the game, we always have to refresh the browser to be able to restart. So maybe something that we would want to do is let the user restart the game whenever they want throughout the game. And so for this challenge, the task would be to actually implement that logic to restart the game. And so there are 4 tasks to do that. So adding an event input event listener. And the hint for that would be to recall step 2 whenever we actually added the keyboard inputs. And the last 3 are relevant to the restarting. And those would be resetting the snake's position whenever we restart, resetting the input direction, and restarting the game loop. And the files needed for that would be input.js, game.js, snake.js. And I guess another hint for those would be to reset or create a function reset game in game.js. And to be able to see this solution for this part of the workshop, if you want, you can git reset -- hard and check out w1 - challenge to see the solution. And so with that, we're going to go ahead and start breaking for lunch. 1 second.